Next, we are going to discuss about symmetric and asymmetric encryption. Very simple. When we talk about symmetric encryption, we use the same key for encryption and same key for decryption. So you took a plain text information, used a key to encrypt that data. You got this encrypted information, ciphertext, and then when you have to decrypt, the same key can be used for decryption. And that's what we get a plain text information. Like you lock your house, same key is used to lock and same key is used to unlock the house. That is a symmetric key. So same key is used for both the purpose of encryption and decryption. That is symmetric key. The next type of encryption, when to use symmetric or other type, we will discuss that in a minute. Another type of encryption we have is called asymmetric key encryption. Asymmetric key encryption. What we are trying to do here, that we generate a key pair, not a single key, but we generate a key pair, and in that key pair, one key is considered as a public key and another is considered as a private key. As the name says, public key we would share to anyone who wants to encrypt the data. But the ability to decrypt is only with the person who has the private key associated with it. So as the name says private, we won't be sharing it with anyone. We would keep it to ourselves, and through that we would perform all encryption, decryption operation. So in this case, the key pairs are generated and these key pairs are unique. So this key pair, one key of that, which is my public key, is used for encryption, and once I have data which is encrypted, I would use the same pair's private key for performing decryption of the data. Now, what is the use cases for them when I would use one over the other? So let's go ahead and talk about that. So this will give you idea on when and which type of application can be really useful for symmetric or asymmetric encryption. Let's compare. So symmetric encryption encrypts and decrypts data using a single key, one key only. Asymmetric are accomplished using two distinct key, public and private key. Now, as if it is one key, it would be much simpler to perform, right? So symmetric is always simpler due to its simplicity. It is faster. In asymmetric, it is little complex because you have to figure out public and private key pair and then perform encryption and decryption. So it is little complicated, right? And it will little slow down the process. Again, smaller key length, typically 128 to 256 bit, there is symmetric encryption support. When we talk about asymmetric encryption, we recommend longer key lengths like RSA, which is an algorithm. It says that we should be using 2048 bits for our encryption key. So this is how the differentiation is. Asymmetric keys will be complex. Symmetric keys are complex, but not at the extent of asymmetric key. Symmetric is used typically for bulk data encryption. You have huge amount of data to encrypt. In that case, probably you would be using symmetric key, one key which is used for all your encryption. When you are creating, let's say, a hard disk level encryption, disk level encryption, probably you are using a symmetric key for that. Right. Asymmetric, it is used for smaller data transaction, primarily to authenticate and create a secure communication channel before the actual data transfer happen. So this asymmetric is happening most of the time between the client and a server communication. So this is my client, and then this client is talking to a server here. I want to ensure that client is right, legitimate, and then we want to authenticate, and that is where we will be using a asymmetric key to create a channel, and once that channel is established, we would then start transferring data over it. So that is client server communication, which is a very common thing which is used for asymmetric encryption. Now, ciphertext size is not much different from the original plain text. The output which is coming up is not very different. Asymmetric ciphertext is bigger than the plain text because it has to be protected in a way that only private key can open it, and that's why it would be little more lengthier than the actual text which we have provided. Now, when I'm saying text, it does not mean just characters. It could be any ones or zero, any numbers which we can encrypt using these methods. Now, symmetric key not used in digital signatures. Signatures are a way to verify authenticity of a particular site or a domain or a particular service. So symmetric keys are not used for that. Asymmetric keys are preferred in digital signature. talking about what algorithms are symmetric versus asymmetric, if you heard about DES, RC4, 3DES, AES, CHA-20, these are all symmetric key encryption, whereas asymmetric is DSA, RSA, Diffie-Hellman, ECDSA, ECDH. These are considered as your asymmetric encryption. So I hope this thing is clear and you have a better understanding of what is symmetric versus asymmetric. Just to give an example, let's say when you have stored a doc into a Google Doc or into Amazon S3, what we will be doing, we would be using a symmetric key for encryption. But when you are making, let's say, a transaction over HTTPS, or you are connecting to a website on HTTPS, that is where browser-based communication which is happening through asymmetric encryption. Or when services are talking to each other, probably they are using a asymmetric key for creating that secure channel for communication. So hope this thing is clear. We'll discuss a little bit more on how a key pair is generated. So let's talk about that. So when you have to generate a key pair, you would need a service who would help you in generating a key pair. I'm talking about here asymmetric encryption. So to that service, you will take large random numbers which will be generated, as the name says, randomly. So we will generate a random number. We would have a key generation program and that would then generate the keys for us. So this is how my key generation would be accomplished. So large random number, and as it is random, next key I'm generating using the same key generation program would be different, and then those keys can be tagged or used for different purposes. It purely depends on your use cases. So how encryption works in AWS? Obviously it is a lengthy process, but I'll explain you some basic detail. Let's consider that we most of the time use these two type of encryption while my data is moving from point A to point B, and then encryption at rest when B has stored that data into some storage volume, and that is where my data has been stored safely. That is where I would be using encryption at rest. So encryption in transit happens when my services are talking to each other, or I am sending requests to a server. That is encryption in transit. Whereas when my data has been stored onto a optical drive or a disk or a volume or a file system, that is encryption at rest, which happens there. So consider that we have a standard application in AWS. There is an entry point for application, then there is some front end or processing tier, then we have storage. Entry point for your application could be load balancer or API gateway or CloudFront, doesn't matter. You may process this information on a EC2 or container or Lambda, and then at the back end, your storage can be on Amazon S3 or Glacier, DynamoDB, EFS, FSX, purely depends on your choice. Now, you expose your application so your users start communicating over internet to your application. What I need now, whatever data my users are sending, I want it to be encrypted in transit while it starts from my user's request and received by my service. I want to ensure encryption, and that is where encryption in transit happen. Encryption in transit is used by SSL, or is achieved by SSL TLS certificate, which is again has the key pair concept, public and private, and through which we are able to perform all the encryption and authentication of the services which we are using. In AWS, the service which helps you in achieving this is called AWS Secrets Manager, and through that you can generate SSL certificate, rotate it, apply it to services which are entry point or front ending, and maintain it if the need be, and audit it if the requirements are. So that service is Certificate Manager. Generate certificate and assign it to your front end or entry points. When it comes to encryption for storage, that is what we mean by encryption at rest, and that is where the service comes into picture, which is called AWS Key Management Service, or KMS, and that is where we generate encryption keys and through which my data is encrypted. And once these keys are generated, we could leverage it and then say, okay, KMS, go ahead and use encryption keys for my data. Now, one thing you have to be aware about encryption in KMS is that a lot of time people think that how KMS work. Let me try to draw it and then I'll explain how it does not work. So let's say this is my KMS service. I have this S3 bucket and I have a file, or what we refer as object, to be stored into S3. What people think that when we say I want to use KMS for encryption, they assume that your object will be first sent to KMS. KMS will perform encryption of the object which has been sent to it, and then it will be stored into S3. This is what is common assumption, is that KMS encrypts the object, or it could be file or whatever it is. Answer is it does not work like that. Let me explain how it actually works into KMS scenario. So you have still the same thing. You have your object here. You have your KMS service, and then you have your S3 bucket. Now, whenever S3 has to store this object, so you send a request to S3 and say, hey, S3, please store my object and use key which is called key number 1, and that key number 1 is having its origin in KMS. So what happens now? When S3 receives a request that, okay, I want to encrypt object number 1 with key number 1, which is in KMS, S3 goes to KMS and KMS returns to it something called a data key. And that data key, let me call it DK1, is then used to encrypt the object, and that encrypted object is now stored into Amazon S3. So it is not that a KMS goes and encrypts it. KMS generates the keys and the services would encrypt it. Like here it is S3, same thing. Let's say you were using DynamoDB. So DynamoDB service will talk to KMS, generate a data key, and through that your data would be encrypted. That's how KMS architecture is. If you want more information, check my security training where I have explained with demos all this information, how it is actually utilized. So I hope this thing is clear and you got a better understanding of what is encryption and how it can be implemented in AWS. Thank you.